So hey guys, Stinky Cash here. Today I wanted to talk about the moon. Last month, as you know, was the infamous blood moon. It had the entire mainstream media going nuts about the moon. The moon was all the rage last month and everyone was talking about it. But in this video, I want to talk about the phases of the moon and what causes them, how they occur. And I made some visual aids to make this easier for you to understand. But let's start off by going to Google and typing in lunar day. And when we type in lunar day and we click on the Wikipedia link, we could skip over this top definition, and what I'm interested in is this alternative usage definition. Now, the alternative usage definition says, the term lunar day may also refer to the period between moon rises in a particular location on Earth. This period is typically slightly longer, 50 minutes, than a 24-hour Earth day, as the moon revolves around the Earth in the same direction as the Earth's axial rotation. Now, a lot of that is bullshit, but what is important here is that it says one lunar day is 24 hours and 50 minutes. So if one solar day is 360 degrees, and we could round up to make this a little bit easier. If there are 24 hours in a day, that means the sun moves 15 degrees per hour in the sky. One lunar day, which is one 360-degree circle of the moon above the flat Earth, divided by 24.83 hours, or 24 hours and 50 minutes, that's roughly 14.5 degrees per hour. So the sun moves 15 degrees per hour, but the moon is slightly slower. It only moves 14.5 degrees per hour. This means that the moon loses 1/2 degree on the sun per hour. So if you calculate that for 24 hours in one day, that means the moon loses 12 degrees on the sun per day. 12 degrees per day times 30 days, which is roughly one lunar cycle, that gives you your 360 degrees. It's this 12-degree loss per day that causes the phases of the moon. So let's start off by taking a look at this image I've created. As you see, I've rotated the flat Earth map so that my longitude here in New Jersey is lined up with 180 degrees south, or noon, solar noon. Okay, solar noon is subject to change. During daylight savings, it's pushed back an hour, and depending on your location and your time zone, it could be different. So we can go on timeanddate.com and look up solar noon times for Atlantic City, New Jersey, which is pretty close to where I live. And it says that on October 27th, 2015, solar noon will be at roughly 12:42 p.m. So we can go back to my visual aid here. This is an image of solar noon at 12:42 p.m. for Atlantic City, New Jersey. The sun is directly south of my location. Now we could fast forward 12 hours, make the sun and moon rotate in the sky. And 12 hours later, we're going to reach what I call solar midnight. And at solar midnight on a full moon, the moon will be exactly 180 degrees south of you. That's because during a full moon, like tonight, the sun and moon are exactly 180 degrees opposite each other. But what happens is if you were to take a look at the moon tomorrow night at the exact same time at 12:42 a.m., the moon's not going to be in the same spot. The moon is going to have lost 12 degrees over the course of that day. So now the moon is going to be here at 12:42. It's lost 12 degrees. The next day, on the 29th, the moon will be here at 12:42 a.m. And then here, and then here, and then here, and then here, and so on and so forth. And the moon will continue to lose 12 degrees per day. And when this happens, this causes the lunar phases. The lit side of the moon always faces the sun. So because the moon is slightly slower than the sun, it loses 12 degrees per day. And the change in the moon's positioning in the sky relative to the sun causes the lunar phases. Now, technically, the 100% full moon in Atlantic City was on October 27th at 8:05 a.m. And this is what that would look like on the flat Earth. I've set up my flat Earth map to be a 24-hour clock, and I've positioned my sun at 8:05 a.m. and I've positioned my full moon exactly 180 degrees opposite of the sun. So this is where the moon was in the sky when it was 100% full. Now, the positions of the sun and moon relative to each other in the sky causes the lunar phases, but this does not cause the lunar eclipse that we saw last month. The sun and the moon were in the exact same positions relative to each other that they are during every single full moon. Okay? Nothing different happened last month during the lunar eclipse. The only logical explanation that I could come up with is that last month, a third celestial body came down and crossed over the North Pole. And having this third orb in between the sun and the moon causes the lunar eclipse. So this month, the 100% full moon was at 8:05 a.m. But last month, the full moon was at 10:50 p.m., which here in Atlantic City was the exact time of the lunar eclipse. 10:50 p.m. was the exact middle of it. So that's the moon in a nutshell. I've been studying it for the last few months, for about 4 or 5 lunar phases now. I've been observing and studying the moon. I think I've got it down to a science, and I believe that this is exactly what happens in the sky. The sun and the moon are creations, and they work in tandem with each other, and it is a work of art. It is absolutely perfect the way this works. The sun is the hour hand on a 24-hour clock. It gives us our days, it gives us our seasons, and the moon keeps track of the months. The months. We're 30 days, 1 month, 1 lunar cycle. So that's all I got for you today. I hope this video was informative. I hope you learned something. I hope you enjoyed it. If you did, please give me a thumbs up. And if you have any questions, please leave them in the comments of this video.